Hello guys, welcome to this lesson about trigonometric identities. I believe you're going to enjoy yourself as much as I will. And as you can see, here we have two problems that we'll be discussing in this lesson. And of course, what I encourage and advise in mathematics is to be, take an inquiry approach towards it. In other words, if you know what the problem is, you're likely to know how to solve it. Okay, so look at what you're given. What does it mean? What is the problem? And thereafter you formulate a what? A solution to the problem. Okay, let's start with number one. What do we have here? We have an identity. However, on the left-hand side, we have a product of binomials. Okay, and then we're moving into something that just has a 5 sine square x minus 1. We start with something with a cos. Somehow there's no cos on the right-hand side, meaning that mathematically we need to maneuver and use identities that will eliminate this cos square somehow, or through cancellation of terms perhaps that may happen to cancel that cos. So in an identity you must choose which side you want to start with, either left to right or right to left. Okay, and the nature of the identity of course will dictate sort of for you what to do or which side to choose. But this one, product is fairly easy to expand the product and see what happens with it. So we can definitely start on the left hand side and move in this direction and prove that we can get to the right hand side. Okay, so let's see what happens. Left hand side. Okay, so we have a product here and then we expand it. Okay, so it's 2 sine x times 2 sine x. We end up with 4 sine square x. 2 sine x times a negative cos x, it becomes minus 2 sine x cos x. And then cos x times a 2 sine x is plus 2 sine x cos x. And then positive cos x times a negative cos x becomes a negative cos square x. Okay, so then what happens? We can see the cancellation of the two terms here. It is the same thing with opposite signs. Okay, and therefore it falls away. What are we left with now? We have 4 sine square x minus cos square x. All right, so if we are comparing the expression that we are heading to, we have 4 sine square x. We're looking for the 5 sine square x. So we need to take care of this cos square x because we don't need a cos term anywhere on the right hand side. So of course we can produce its equivalent identity here, and it becomes 4 sine square x minus what? 1 minus sine square x. Okay, and we eliminate the cos in that way. And then what do we see? Of course, distribution of the negative here, we have a 4 sine square x minus 1, a double negative produces a positive for you, and it's a sine square x. Okay, grouping your like terms here, you end up with 5 sine square x minus 1. Now compare what you have with the right hand side. Have we proved? Yes, it is a sufficient proof of the identity, and we'll leave it at that. Okay, well, that is fairly straightforward. Now I challenge you now in your own time to start on the right hand side and move in that direction. Okay, that is possible. All right, so give it a thought and see if you can start here and move in that direction. Good stuff. Now let's come this side. Okay, here we have our second problem, and the left hand side is a fraction, the right hand side is a fraction inside a square root. Okay, so this one now, when you have a square root, it's obvious in terms of where you need to start. Okay, if you start here and you want to end up with something with a square root, there's a lot of manipulation that needs to be done, and it may take you a long time perhaps to even get there. Okay, however, to start with the square root and eliminate it, it's relatively easier to do that. Okay, because you just need a term with a square to cancel the square root, and that's how you eliminate the square root. Okay, so in other words, in this identity, it would be wise then for us to start on the right hand side and move in this direction. Okay, so let us see what we can do mathematically to prove this identity. So on the right hand side, look at this. We have something with a cos, 1 minus cos. We are moving to something with a sine x. That brings into mind an identity, okay? 1 minus cos square x, yes? Okay, and look at this. Our denominator is 1 plus cos x. It does not change. It remains as 1 plus cos x, okay? However, the square root again is not there. So that is an indication that somehow we ended up with a power of 2 for this binomial, and it cancelled with the square root. Okay, so already in your mind you built that mental mathematical roadmap, if you like, of what has happened or what needs to happen to get there. All right, so let's do that. Do understand that here we need to produce a 1 minus cos square identity so that we can have this sine x forming through the cancellation of the square root. So how will we achieve that? Okay. We can rationalize here, okay, the numerator, and then we multiply it with this binomial right here. Why are we multiplying by this? Because here we understand that we're going to produce a difference of 2 squares, which will constitute our identity and therefore produce our sine x that we need. However, everything that you're doing is taking place inside the square root. So don't forget this important symbol here. And I want to emphasize, you must cover everything with the square root. Don't end halfway and leave it there. All right, let us just be mathematically sensible as we structure our proofs. Okay, good stuff. Now let us simplify here. What's going to happen? Here is a difference of 2 squares, so it's 1 minus cos square x. Okay, if you don't see it, you're welcome to expand it. Write it in terms of a product of 2 binomials like here, and apply the FOIL method, and you will definitely end up with a difference of 2 squares. Okay, and now look at this one. It is something times itself. So just like x times x is x squared, 1 plus cos x times 1 plus cos x will be 1 plus cos x all squared. Everything is taking place inside the square root. Okay, good stuff. And now look at this. What does this give us? It's an identity. Okay, 1 minus cos square, it is sine square x. All right, and this is over 1 plus cos x all squared. We don't need to do anything with this or any manipulation because we are heading to just 1 plus cos x. All right, and this is taking place again inside a square root. Good stuff. The cancellation happens here because now we can write this as sine x over 1 plus cos x. Look at the left hand side. We definitely want this. All right, and mathematically through exponential laws we can write it like this. Okay, and take this square and just represent the entire fraction with just 1 power or 1 square. Okay, and what's going to happen here? A square is the inverse operation of a square root, so the cancellation there happens and we are left with sine x over 1 plus cos x, which is equal to the left hand side, as you can see. All right, so guys, this is really the way to go about being effective with trigonometric identities, and this is grade 11 work or level, and I believe that I was able to clarify it for you and give you some tips and hints that will be to your benefit. All right, so I'm gonna leave it here. I believe if you enjoyed, remember this homework, go in this direction and prove it for yourself that indeed you can end up with that product of a difference of 2 squares. So yeah, thank you very much for tuning in. See you next time. Sharp, sharp.